Well, the title says it all here. This is a ridiculously short intro to color theory. Color theory is a dense topic. It's a wonderful thing, and it takes years and years of study, but we have to start somewhere. So as you watch this presentation, keep in mind the following. The best way to learn color theory is to take a painting class from a good teacher, because mixing paint is the best way to get a sense of how colors relate to each other and how to best design like a color palette for work. So that's the best case scenario. Not everyone has that opportunity, unfortunately. There is a lot of resources online that I'll try to point you to. After you watch this presentation, if you're just a beginning student, the main thing I want you to know is you cannot choose your colors randomly. Okay, the color scheme, which is also called a color palette, and I'll have this PDF on Blackboard so you can read it. The color scheme is designed with intention. All right. The other thing, if you're a beginning student, the other thing that be aware of that a typical beginner's errors with color is this. Most beginners use really oversaturated bright colors, and like every color in the work is extraordinarily bright, and that goes for both design classes and beginning painting classes. So just be aware that most beginners like really throw the bright colors on the canvas. You might be conscious that you might want to mute your colors or turn it down. Another thing beginners make a mistake with is colors that are too close to each other in hue. For example, like green on aqua. Like using like an aqua type on a green background or something like that. If you're into music and you go up to a piano, and if you hit the two white keys close to each other, a lot of times it sounds weird. Okay, it's the same thing with color. If the colors are too close together, they create this disharmony. The other thing, this last thing I have, this is kind of a, maybe I shouldn't say this, but because it sounds like snarky, a lot of beginning students for a color scheme will use black, white, and a splash of red. Yeah, that's okay. You'll see a lot of professional work, especially in video game design, where they use the black and white with a thing of red. Like, for example, there's a real famous poster of Scarface with Al Pacino that uses black, white, and red. That's fine. That's okay. There's no law against it. But just realize that a lot of beginning students will use that black, white, red theme as kind of a cop-out, and it's seen quite a bit. Okay, so the colors that you see are part of the visible spectrum of the electromagnetic spectrum. So we have, you have radio waves, microwaves, infrared, visible light, and it goes all the way to through X-rays and gamma rays. All that stuff comes out of the sun. Okay, yeah, radio waves do come out of the sun. Not kidding. Radio waves are being propagated out of many towers in an urban area, and they're passing through your body. All right, so visible light is just one small tiny part of this huge electromagnetic spectrum. The other thing I want to talk about, the light you're looking at on a screen is projected through a screen. You're looking at pure light. All right. Now, if you just glance over your shoulder, look at any object, for example, if there's a blue book on the table, what's happening is all the light in that blue book is being absorbed except for the blue. The blue is being reflected. So let's think of a yellow school bus. You see a yellow school bus on the street? All the light, all the sunlight is being absorbed into that yellow school bus except the yellow, which is being reflected back. Okay? So now before we talk more in depth about color, there's two basic color models that you're going to work with as a designer. Rgb is one of them. That's anything that's on a screen is in the Rgb color model. And what the heck does that mean? That means there's the devices you're looking at, including the one you're looking at right now. uses a stream of red, green, and blue lights, mixes them together to create the full range of colors that you can see on a screen. So it's pretty amazing. You can, just by using red, green, and blue, adding them together, layering them on top of each other, or putting them together, you can create any color. So that's called an additive color model. Okay, if you put equal amounts of R, G, and B together, you get white. It's not you. The screenshot I'm showing you here is pretty pathetic, but it's you put them all together, you should get a white. You can get a pure white. So RGB is very pure. It's called an additive color model because you're adding colors together, and as you add them, they get closer to white, or a pure light. Okay. Now in print media, what you're going to work with a lot as the designer is called the Cmyk model. Cyan, magenta, yellow, black. K for black. And here they are pictured here. They're at an angle for a reason. When these colors are printed on paper, they're printed at these angles. And if you ever scanned in a magazine photo and you see some funny looking wavy lines on it, that's called a moire pattern. If you ever got two screen doors, and you look through two screens at the same time, I'm sure you've done that. You've seen that weird wavy pattern. That's because these dots are printed at these different angles. And they're printed at these different angles to give a richness to the color in the paper. So these four colors are transparent inks. Okay, that's an important thing to know when you're working with print media, that these are transparent inks that are laid on top of each other. So you have these enormous presses. They have four rolls on them, and they literally have the four different inks on each roll. So the first roll will create a yellow image, the second one that has only magenta ink in it, the third one only has cyan, and the fourth only has black. Now as these are layered on top of each other, these images are layered on top of each other, they create the images that you see below. Okay, the black is the last one. It's called a lock. And so if I went back up here, the cyan, magenta, yellow, black is called a subtractive. Okay, now how does that make sense? You're still layering color on top of each other. Why is it subtracting? Well, you're subtracting light. Okay, theoretically, if you put cyan, magenta, and yellow together, you get a black. Doesn't work in real life because the pigments are not pure enough. You get this really yucky brownish green. It looks really, really ugly. So that's why they have to have a nice pure black ink all by itself. So put these colors together, you're subtracting light. You put these colors together, you're adding light. Okay, that's why it's called additive and subtractive. Okie doke. The properties of color. Whoopsie, sorry about that. Properties of color: hue, saturation, and value. Hue is just the name of the color. That's like a leafy green on the right there at the top. It's actually the wavelength of the light. So blue has a wavelength, green has a wavelength. You can refer back to that first cell I showed about the spectrum. So hue it's not brain surgery. It's the name of the color. It's the wavelength. Okay. Saturation, we call it. Digital artists will call it saturation. A lot of fine artists who do oil and acrylic will call it intensity. And they're both legit. It's the purity of the color. So in that first row of three there, the less saturated is on the left, the original color is in the middle, and the more saturated is on the right. So it's a purity, less purity is called saturation. The last property that a color has is value. A shade of the original color, you add black to it, you get a shade. Add white to it, you get a tint. So that's good to know. Okay, a tint of the original color, add white. Shade of the original color, add black. So those are the properties of color, whether you take a painting class work in print media or work with the RGB model exclusively, you're talking about hue, saturation, and value. Alrighty? This is the color wheel. If you look at this, what this is the spectrum kind of like folded onto itself, really. And the main thing that at this stage that you want to know about are the concept of complementary colors. All right, so let's pick a yellow. Okay, over here, if you can see the cursor. The complement is the thing that's 180 degrees from it. So I'm going to go this way. The complement of this guy is like this light violet purple. You know, violet and purple is the same thing. Let's see. Let's take a look at like a nice green color. The exact opposite is like this reddish hue, red and green. Okay, you've seen those together, I'm sure. So the strength of knowing what the complement is like if you want to create a contrast. If I have a yellow, I want to create a nice contrast, I know I'm going to go to this side of the color wheel and use one of these colors. You can buy an El Cheapo color wheel at a craft store for like $2 or $3. They're good to have when you're just getting started. I recommend it. Okay, what is this? Okay, this is going to kind of solidify what I mean by complementary colors. Don't take your eyes off the screen. I'm not going to look at the black dot and let me just talk you through. I want you to like stare at this, just look at the black dot for about 45 seconds and I'll keep time for you. And no, I'm not going to hypnotize you and make you go on Amazon.com and buy stuff or anything. So look at the black dot, keep looking, keep looking. Yes, I'm serious, keep looking. Don't blink, all right? Just humor me. All right, so you're looking at the black dot, keep looking at it, don't blink. Now what color do you see? Did you see a flash of a color? You might even still see an after image of it. Well, that is a physiological phenomenon, that after image that relates directly to the color wheel. Alrighty? So that, yes, teacher picked it on purpose. Okay, like I picked the yellow, and the after image, you should have seen something in this range of this, like this light violet. Alright? Okay, well, so what? Well, let's keep going forward here. So what I'm saying is that this wheel of color, people didn't just make this stuff up, all right? This is the spectrum of the electromagnetic spectrum, like kind of like folded into a circle, alrighty? That complementary color stuff it's a physiological phenomenon that whenever we look at orange, this is a really awful screenshot. Some of these colors are wrong. So, but like like an orange will be opposite of a blue, and that's that little demo I just showed you with the after image should show there's a physiological connection with your retina, your eye, and how we perceive colors. The one thing that I use a lot and I find useful in designing, especially in logo design, is this thing of split complementaries. This is not a strict split complementary. A split complementary is you take a color and you go across and just adjacent to it, this is the opposite, red. The opposite of red is green. There's a near opposite, okay, like this yellowish green. There's also like a somewhere between green and blue, an aqua. So that's a split complementary, which you'll be working with in another exercise. And let me see what else I got here. The other thing, I hope you're still awake. Remember that colors change their appearance depending on their backgrounds. Okay, for example, here we have red on white, no surprises there. We put it on black, the intensity of the red increases. What's another good example here? This yellow on gray, I mean, that really pops out. Or look at this yellow on a violet. See how much more intense it is than just on the white. So your eye will read colors differently depending on their backgrounds. And a real key thing to, whoops, sorry about that. A real key thing to start with is this idea of complementary colors. Okay, like have an awareness of the color wheel, have an awareness that there's an opposite. Each color has something 180 degrees from it, which is a complement, which is a direct contrast. If you can start there, if you're a beginning student, if you're off to a really good start, okay? Because everything kind of builds, all color theory kind of builds off that one simple concept.